So if you're watching this video, you're probably working on that stoichiometry homework before the quiz. And so this video is designed to help you through that. It's really only one question with 5 parts. And it will go through some of the stoichiometry calculations that you should know how to do. All right, and so the first question, of course, is you have to start with a balanced chemical equation. When you're doing stoichiometry, the equation has to be balanced. And so that is the first thing. So hopefully you're kind of doing inventory on each side. You notice there's 1 K on the left, 2 on the right, 2 oxygens on the left, 1 on the right. And so to balance it, you'd have to add the coefficient of 4 in front of K and 2 in front of the product K2O. And the oxygen gas is just fine the way that it is. Then the first question says to calculate the molar mass of the product. So that's assuming that you can determine which one of these chemicals is the product. So if you're taking a look at it, what is the product? So we've got these two. Are those the product? Or is this one the product? Hopefully you were thinking K2O is your product. And so in order to calculate the molar mass of something, I need my periodic table, which I just happen to have in front of me. Then I've got to look at what elements I have. And so I can see that I've got K, and the molar mass of K is, oops, and that is a typo. The molar mass of K is actually 39. And we're going to need to multiply that by 2. The molar mass of oxygen is 16. And as we multiply that 39 times 2, add 16, you should come up with the molar mass of K2O. Let me do the quick math here, as 94 grams per mole. And obviously I have a typo there because for some reason I was thinking the molar mass of potassium was 30, not 39. And so this number should actually be 94 when I do that math. And you should do that math to double check it, to make sure that you've got it as well. And so what that means is if we wanted to get 1 mole of K2O, we'd get 94 grams. The next question says, how many moles are in 10.12 grams of potassium? And so the first thing you want to do is you want to take a look at what's given. And obviously in this case, I'm given 10.12 grams of potassium. And that's the first thing you're going to want to write down. Now, if I have grams and I want to convert to moles, the next thing I need to be thinking of is how am I going to convert from grams to moles of potassium? What do I use? Hopefully you were thinking the periodic table. And so I'm going to be looking at my periodic table for the molar mass of potassium. And I know that when it comes off my periodic table, it's grams per 1 mole. And so I know I'm going to want to put these grams down here so that my units will cancel out and my moles will go on the top. The other way to kind of think of that is that I know I'm looking for moles. So those are going to need to go on top of my fraction. And so simply putting that in and doing the math. Multiply right across, 10.12 times 1, then divided by 39, 0.259 moles of potassium is all we would have there. Question C asks how many moles of O2 would be required to use up those 10.12 grams of potassium. Now, once again here, I'm looking at what's given. I know I've got those same 10.12 grams of potassium that I had for letter B. So I could start there, or I could simply take my answer for letter B, and that was what I did. I said, okay, so if I have my 0.259 moles of potassium, and how am I going to get to moles of oxygen? Because that's what it's asking me to do. So when you have moles of one chemical, how do you find moles of another chemical? Hopefully you're thinking, well, you're going to use the mole ratio from the balanced equation. And that's why I've put our balanced equation here, because I can see from my balanced equation that 4 moles of potassium is equal to 1 mole of oxygen. And so that's what we're going to do there, because we don't want to run out of one of our reactants first. So if we're going to use these 10.12 grams of potassium, we want to make sure we have enough oxygen to get as much K2O as possible. We don't want that oxygen to be our limiting factor that we would run out of first. And so that is super important. And so simply by taking a look at that and jotting that down, then go straight across the top and multiply 0.259 times 1, and then of course divided by 4 is going to give you 0.0649 moles of oxygen. And I'm just going to check my math again here one more time, because that's again the place where you're most likely to make a mistake. All right, now moving right over to the back, E says how many moles of product could be theoretically produced from those 10.12 grams of potassium. And so now I'm going to be looking, if I used that 10.12 grams of potassium and I used 0.0649 moles of oxygen, how much K2O would I make? Of course, I'd probably want to convert those moles of oxygen to grams of oxygen so that I could get the correct amount. And so I'm going to start again with those moles of potassium that I had calculated back in letter B, because I know that I've got 0.259 moles of potassium. And I'm trying to figure out how much K2O I can make with those 0.259 moles of potassium. And so now I'm going to look at my balanced equation, because I can see that I have a 4:2 or a 2:1 ratio. I know a lot of you like to reduce that. I like to leave it as it is, of moles of potassium to moles of potassium oxide. And so I'm going to put those 4 moles of potassium on the bottom. That way they're going to be able to cancel out. And I'm going to put those 2 moles of K2O on the top. And calculate the moles of K2O. So I'm going to multiply 0.259 times 2, then divide by 4, and I'm going to do that all that in one step, and I'm going to get let me see if I can erase that. I'm going to get 0.1295 moles of K2O. But this problem asks for grams of K2O. So now that I've got my moles of K2O, I know that I'm going to make 0.1259 or 95, moles of K2O. We are going to go ahead and figure out how many grams of K2O. So anytime that I'm going from moles to grams, what do we use? Hopefully you're thinking the periodic table and that molar mass from the periodic table. You are exactly right. Now, of course, earlier in 1A, we calculated the molar mass of our product, and we know that that is 94 grams. And so what I will do is put my moles here on the bottom. That way they're going to cancel out whenever it comes off the periodic table. It's always 1 mole of whatever it is, and we know that that is 94 grams of K2O. And then so we're going to simply multiply right across the top and then divide by 1. And 0.1295 times 94 is 12.17. So if we were to do this activity, we would get 12.17 grams of K2O. That number is called our theoretical yield. Of course, if we were going to do this in the lab, we could then measure our actual yield to determine our percent yield. I hope this helps you with the homework and will help you with your test.